Welcome back to it. It's Math Masterclass with Leo. Today we're doing grade 12 basics trigonometry, right? So what we'll be focusing on today, we'll be focusing on what you call special angles, right? So, but for special angles, what you need to know, you need to be able to use SOHCAHTOA, right? If you can be able to use SOHCAHTOA, then you'll be able to understand easily the special angles, right? With special angles, most teachers they advise students to or learners to climb the table. What I'll say to you, if you can understand the diagrams, if you know the diagrams, then you can do your own table. Know these two triangles, then you can draw your own table. Right? If you know these two triangles, you can just draw your own table. Right? Here, you will have this is 2, this is square root of 3, this is 1. Right? Here it doesn't matter if you use 60, use 30, it's up to you. But even if I use 60, use 30, our solutions are going to be the same. They'll never change. Right? In this case, let's use 60 degrees and 30 degrees. Together they make up to 180 degrees. Right? So then you'll have another drawing, which is like that. Okay, fine. This is 90 degrees. This is 45. And there is 45. Right? Then this will be square root of 2. We'll have 1 here and 1 here. You can draw your table. This is your theta. Then you'll have your 0 degree, your 30, your 45, and your 60. These are special angles. Special angles. Right? Now, here I'm going to have sine. I'm going to have cos. And then here I'm going to have tan. Right? When I say sine 0, I'm going to get 0. When I say cos 0, I'm going to get 1. And when I say tan 0, this is 0. Then when I say sine 30, I'm going to look at this. This is my angle. This is the angle that I'm looking for. Or that is my reference angle. If that is my reference angle, means this is my opposite side. Right? That is my opposite side. Now, if that is my opposite side, meaning this will be my adjacent. If this is my adjacent, that is my hypotenuse. Now let's see. SOHCAHTOA says if I'm looking for sine 30, I must have opposite over hypotenuse. So my opposite in this case is 1, and my hypotenuse is 2. So I'm going to have over 2. A solution, right? Now, when I say cos theta is supposed to be adjacent over hypotenuse. In this case, if 30 is my reference angle, it means square root of 3 is my adjacent side. So I'm going to have square root of 3 over 2, right? And then if 30 is still my reference angle, and I'm looking for tan is opposite of adjacent. So my opposite is going to be 1. My adjacent is going to be square root of 3. So in this case, I'm going to have 1 over square root of 3. Right? Then let's jump this. We'll focus on it. We'll come back to it. Let's come to 60. Now 60 is my reference angle. Right? 60 is my reference angle. Right? 60 is my reference angle. This is my reference angle. This will be my opposite, right? Then if that is my opposite, meaning 1 is my adjacent, then 2 is still my hypotenuse, because most of the teachers will say it's the longest side. I'd say it's the side that is opposite to what? It's the side that is opposite to my 90-degree angle, right? Because sometimes they won't draw these things to scale. You think all of them are equal. How do I identify that this is my hypotenuse? You look at the side that is opposite to your 90-degree angle. If it's opposite to your 90-degree angle, that side is your radius or your hypotenuse, right? In this case, 60 degrees is our reference angle. Then it means square root of 3 is our opposite, right? If I'm looking for side opposite of hypotenuse, it means there will be square root of 3 over 2, right? That is my solution. And now let's say I'm looking for cos theta. Why is cos theta? If this is my opposite, then 1 is my adjacent. That means I'm going to have 1 over 2, because 1 is my adjacent, 2 is my hypotenuse. So this will be half, or 1 over 2. Right? The solution of cos 63. Now, when I come to tan 60 degrees, 60 is my reference angle. Then square root of 3 is my opposite. 1 is my adjacent. Then I'm going to have square root of 3 over 1. That is my solution, right? Which actually is square root of 3. Right? Then now, let's come to this diagram. Let's come to this diagram. With this diagram, what is sine 45? Sine 45, my opposite is 1, because let's say I'm using this as a reference. Even if I'm using this as a reference, my opposite is still 1. So I'm just going to use that. That is my opposite angle. Opposite to what? Opposite to this 45. So I'm going to have my opposite as 1 over square root of 2. Even if you use this as your reference angle, I'm still going to get 1 over square root of 2. Right? So my solution here is 1 over square root of 2. Right? Then when I come to cos 45, adjacent of our hypotenuse, what is my adjacent? Adjacent is 1. Then my hypotenuse is square root of 2. So it means I'm going to have 1 over square root of 2 here. Right? Then let's come to the next one, which is tan. Right? What is tan 45? I have 1 over 1. So my adjacent is 1, my hypotenuse is 1. My adjacent is 1 and my opposite is 1. So opposite of adjacent is 1 over 1. This is equals to 1. Right? That is my solution. That is it when it comes to special angles. See, you no need to cram the table, but understand and know the two triangles. Therefore, you can use those two triangles to draw your own table. Right? Now, the next thing that we are coming to is reduction. Right? Reduction. So with reduction, formula, right? Reduction formula. So with the reduction formula, you just need to know this. This is your 0 or 360. This is your 90. And this is your 180 degrees. And this is your 270. Right? Then we say all students can do that. Okay, all students take coffee. Where in the fourth quadrant, we also have negative angles. Forget that. In the fourth quadrant, we also have negative angles. Now, let's say sine of 180 minus theta. Right? When you say sine of 180 minus theta, you're saying now I'm on a 180 line, which is this straight line, but now I want to go back to this part. I want to go back to this side. When I go back to this side, I'm going back to the side of sine, where sine is positive in that quadrant. Then this will give me sine of theta. Right? And let's come to sine of 180 plus theta. Right? Now, when I say sine of 180 plus theta, this is the line of 180. But now, I'm pushing it this side. I'm coming this side. If I come this side, I'm coming to the side of tan, or the quadrant of tan, where tan only is positive in that quadrant. Therefore, this will be negative sine, right? That will give us negative sine of theta. Now, let's come to cos. Not cos, but let's come to sine of 360. This K. Okay. You have sine of 360 subtract theta. When you say sine 360 minus theta, in this case, you are saying this is the 360 line, but I want to come back to this side, right? When I come back to that side, I'm coming back to the side where cos is positive. Only cos is positive in this side. Therefore, my sine will be negative. Negative sine of theta, right? Is here. Okay. Okay. Now we're coming to the sine of 360 plus. What will happen if you say sine 360 plus? This are very much important when you are simplifying and you are proving. Reduction formula is very much important. You need to know it and you need to understand it. No need to cram. You just need to understand it, right? If you understand reduction formula, then it will be easy for you to simplify and prove, right? So now, what will happen if you say sine of 360 plus theta? Sine of 360 plus theta. In this case, I'm saying sine of 360 plus theta, it means I'm coming this side, right? I'm coming to all, which is quadrant 1. In quadrant 1, all sine, cos, and tan are positive. So in this case, my solution will be positive sine of theta. Right? My solution will be positive sine of theta. Now we're done with sine. The only one that is left is Coratios. But now, before Coratios, let's come to cos of theta. Okay. Okay, there's one more I didn't do of sine. Sometimes they'll ask you, what is yeah. Sometimes they might ask you sine of negative theta. Remember, negative theta, you only find it in the quadrant of cos, which is the fourth quadrant, right? So in the fourth quadrant, only cos is positive. Therefore, this will give you a negative sine, right? Then that's it with sine. Let's come to cos. Okay, so you're looking for cos of 180 minus theta. Now, when I'm saying cos of 180 minus theta, 180 minus theta is the quadrant 2. That quadrant, only sine is positive in that quadrant. So when only sine is positive in that quadrant, therefore your cos will be negative. The solution will be negative cos of theta. Right? The cos of 180 plus theta. In that case, if you say 180 plus from this line, you are adding, you are falling into third quadrant where only tan is positive in the third quadrant. Therefore, your cos should be negative cos of theta, right? Then come to cos of 360 minus theta. When we're saying cos of 360 minus theta, we are we are coming back to the fourth quadrant. Fourth quadrant, only cos in that quadrant is positive, right? So in this case, we will have cos of theta, right? Positive cos of theta. Then when you say cos of 360 plus theta, when I'm saying cos of 360 plus theta, we are now saying I'm forcing this line to go to the first quadrant. In the first quadrant, all sine, tan, and cos are positive. So in this case, you'll have positive cos of theta, right? Lastly, let's say you are given cos of negative theta, which is a negative angle. So in this case, because we have negative angles in quadrant 4 where cos is positive, therefore our solution will be positive cos of theta, right? Our solution will be positive cos of theta. Now, let's come to the next one, which is tan. Next page. Now, when you come to tan, a tan of 180 plus 180 minus theta. Let me just draw that diagram first. That we have 0, 360. Then we have 90. Then we have 180, 70. We have all students take, right? A is not visible. So in this case, all of them, all sine, cos, and tan are positive. This is where sine is positive. This is where cos is tan is positive, and this is where cos is positive. And we also find the negative angle, right? Now, when you say tan 180 minus, coming to this quadrant, which is the second quadrant, and in the second quadrant, only sine is positive. Therefore, your tan should be negative tan, right? Then, when you're saying tan of 180 plus theta, 180 plus theta, you're coming to this quadrant, which is where tan is positive in the quadrant. Therefore, in this case, our tan will be positive, right? Now, let's say you're coming to tan of 360 minus theta. 360 minus theta, we're coming back to the fourth quadrant where only cos is positive and where we find our negative angles. So in this case, our tan will be negative tan of theta, right? Then tan of 360 plus theta, tan of 360 plus theta, then this is doing that, 360 plus, we're coming to the first quadrant. First quadrant, only all of them are positive, all sine, cos, and tan are positive. Therefore, the solution will be tan. These are all the reduction formulas that you need to know. Now, let's come to the coratios. Let's come to the coratios. This. This. And then we come to the coratios. Okay. Coratios. These are the ones that are confusing most students, most learners. So with coratios, just know they are changing. Okay, now come to say you are given sine of 90 minus theta. Sine of 90 minus theta. What is sine of 90 minus theta? Because we are saying coratios, meaning now they change. If it is sine, it's going to become cos. If it is cos, it's going to become sine. Those are coratios. And they only happen or they only change when you have angle 90 here, right? When it's 90 minus or 90 plus, that's when you'll have corratios. So in this case, if I say sine 90 minus theta, 90 minus theta, I'm falling into the quadrant. Right? First quadrant, all of them are positive. So because these are corratios, it's going to change to cos. Right? This we call them corratios. Corratios, right? Or some other books, they call them cofunctions. Right? Other books, they call them cofunctions. I call them corratios. So let's say now you have 90 or sine of 90 plus theta. What's going to happen? If you have sine of 90 plus theta, what's going to happen? Now, when I say sine of 90 plus theta, I'm falling into the quadrant of sine, which is going to give me a positive, right? But because it's a corratio, it will change to cos. So I'm going to have a positive cos, right? I'm going to have a positive cos theta. Then let's say I want to know what is cos of 90 minus theta. 90 minus theta. So in this case, if I say 90 minus, I'm falling to the first quadrant where all of them are positive. So this will give me positive what? This will give me positive sine theta. Right? Then if you come to cos of 90 plus 90 plus theta, if I say cos of 90 plus theta, I'm falling into the quadrant of sine, where cos in that quadrant is negative, right? So, but because it's a corratio, it will change to sine theta. Okay, there is this cos, and negative sine of theta. These are corratios, right? These are corratios. So yeah, that is how we identify corratios. Let's see if we can do few of the compound angles. Then we call it a day. Now, when it comes to compound angles, this is new to most of the students, so don't panic. Very much understandable as well. So let's say you have they're gonna give you sine of theta plus x, right? In terms of compound angles, this will give you sine of theta multiply cos of x plus cos of theta multiply sine of x. This we call it corratio, right? Then let's say you are given sine of theta minus x. This will give you sine of theta multiply cos of x minus cos of theta multiply sine of x. Right? These are called compound angles. Compound angles. Compound angles, right? So the next one that we have is cos. So we have cos of theta plus x. What I normally do or tell my students, sine keeps the sine. If you are dealing with compound angle sine, your sign will never change. If it's positive here, it will also be positive here. If it's negative here, it will also be negative here. But with cos, it changes. So this will be cos of theta multiply cos of x minus sine of theta multiply of x. right? This you see, causes the sign to change. Cos causes the sign to change. When you're dealing with cos, the sign will always change. Let's say now we are given cos of theta minus x. This will give you cos of theta multiplied cos of x plus sine of theta multiplied sine of x. Right? Those are compound angles. These are the compound angles, right? So in the next class, we'll be doing identities from grade 11 identities and grade 12 identities, double compound identities. So make sure to like, subscribe, and share the content with your friends. See you in the next video. Thank you.